Hey kids, today we are going to start learning a little more about some of the programs we've been writing. And in our deep dive, we are going to start today by creating our own classes. This unit really, kids, is the anatomy of the Java class. In Unit 2, we learn to use classes and objects that are built into Java or written by other programmers. In this unit, we're going to create our own classes and objects. Do not worry, kids. It is super easy. Remember that a class in programming defines a new abstract data type. When you create objects, you create new variables or instances of that data type. For example, in Unit 2, we created Yertle and Myrtle, two turtle objects created from the class Turtle. And we use the Java string class to create different string variables, also called object references. Kids, there's a video that will go much better in depth than I do here. Please take a minute and watch it. It's pretty much going to explain the below in a much better and more interesting way. You can think of class like a blueprint or a cookie cutter or a factory that produces objects. For example, the class house below is a blueprint of a house, and the objects, which are the individual houses built from that blueprint. You can't live on a blueprint, although it describes a house, but you can use it to build a house and live in those houses. Now again, kids, all this is saying is everything you're going to need in order to make this object, it's going to be found here. To write your own classes, you typically start with a class declaration that's either public, then class. To write your own class, you typically start with a class declaration with public, then class, then the name of the class. The body of the class is defined inside two curly Q brackets. For example, the class house below, then you create the objects of the new house type by class name object equal new class name. And here we just see that we have our public. That means it's going to be able to be accessed by everything. The class is house. Down here, these are just pulling from house. So instead of turtle and yertle, we're using house in my house. Well, that's all it is, kids. Remember that objects have attributes and behaviors. These correspond to instant variables hold the data for objects, whereas the methods code the behaviors or the actions the object can do. A class also has constructors, which initialize the instance variables when the object is created. For example, new house above. And a class can also have a main method, which can be used to test the class. Kids, that's just a very fancy way of looking down here and saying we're creating the parts of the class there. And we've done this before. Let's create a class called person. What would you want to know about a person? Ooh, that's creepy, kids. What do we want to know? It depends on what problem we're trying to solve. In one situation, perhaps creating an address book, we might want to know the person's name and phone number and email. Here's a possible person class with instant variables, constructor, and a method. We have our public class, insert the person. So this is going to be storing person's information. And we have some private string variables here, name, email, and phone number. And what we're going to really do is just set these to that. So string name will be int name. String email will be int email. And then the phone number will be int phone number. So these are just going to get passed along. Then we can give those methods some actual values. So person could be Mr. Rhodes at mrrhodes@gmail.com. That's not really my email address, kids. And then my phone number, 555-555-5555. Kids, feel free to call me anytime. And that's all this is showing right here. Creating them, that's why they're called an instance. We're constructing them to be part of the larger program, and then the methods are the actual numbers there. Run the code below to see how constructor two-person objects and it fills their data. We're just going to go through this code here, kids. Let's go down here. And you see we have our public class person like above. Private string, we have name, email, phone number. And then here we are, kids, just setting those parameters equal to our variables. So name is going to go to int name. Email is going to be int email. Phone number is going to be int phone. So if we come down here to our actual constructor, you can see just like our turtle class, we had turtle T1 new turtle, and then we'd put it in the world, and then maybe the X and Y coordinates, because that's what the parameters were. But in this one, it's name, email, and a phone number. Kids, don't go calling these numbers. And that's all it's saying here. So up here, you're just building it. And in a lot of our programs before, it's been built for you. And down here, we are just getting the information. Let's go ahead, save and run it. And you can see it's just getting those pieces of information. You can see this by just changing some stuff around. Let's just put test right here, kids. Well, let's go ahead and run. And now you see down here we have a test. So this information is just being passed along when we go to print it out. So we're constructing it. Up here, kids, are points. And then down here, we're printing them off. That's all we're doing. Pretty neat if you ask me, kids. Instant variables hold the data for an object. They record what an object needs to know to do the work in the program. Instant variables are also called attributes, fields, or properties. Instant variables in general and on the AP exam should be declared private. Think of private as like your own diary. Ooh. Only you should have direct access to it. In this case, private means that only the code in the class can directly access the instance variable values. Note, instant variables are declared right after the class definition. They usually start with a private and then the type of variable and then the new name of the variable. Private means only the code in this class has access to it. As we go down here, the person class declares 3 private instance variables, name, email, and phone number. These are the things that you might want to know about a person. And creepy things, kids. They're declared at the top of the class and they exist inside the curly Q brackets. The methods of the class share the instance variables. They can access and use them. Once we have created a class like person, we can have many objects declared of that class. The class is like a blueprint or cookie cutter that defines variables and methods of a class. Each object will have their own copies of the same instant variables, but with possibly different values in them. See the little cookie cutter here below. Kids, this is how your phone book in your phone works. You have a insert a new contact, and every time you do it, it creates a new version of that. So anytime you want to think of this, just think of the phone book in your own pocket. Object-oriented program stresses data encapsulation, where the data, instance variables, and the code acting on the data methods are wrapping together in a singular unit, and the implementation details are hidden. The data is protected from harm by keeping private. Anything outside the class can only interact with the public methods and cannot interact directly with the private instance variables. That's what's encapsulated in the pink box above. That's just showing that this can only be accessed within the class of person. When designing a class, programmers make decisions about what data to make accessible or modifiable from an external class. The private access modifier is used to encapsulate and protect the data from external access. Private instance variables can only be accessed by methods within the class in which they are defined. Kids, that just keeps people from creeping around your program and accessing it from the outside. Let's test our knowledge out here. Click on the instant variable declarations in the following. Which one of these are going to be the instant variable declarations? Well, where's the beginning declarations of our variables? It's right there. Well, that should be those two. Methods define what an object can do or the behavior of an object. Most methods are public, which means they can be accessed from outside the class. Some methods can be marked as private if they are helper methods that are just used internally by other methods inside the same class. They will not be accessible outside of the class. The private and public keywords determine the external access and the visibility of classes, data, constructor, and methods. Note, methods define what an object can do. They typically start with public, then a type, then the name of the method followed by parentheses for optional parameters. Methods defined for an object can access and use its instance variable. So think of above, kids. The person class above has a constructor called person, which we will discuss in the next lesson, a print method for output, a main method which runs the whole program. We will also discuss accessors or getters and mutators, also called setters and modifiers, in the next lesson, which will allow get and set access to the instant variables. We'll get to that in a minute, though, kids. Here's some examples of the print method that prints out all of the data stored for a person object. Notice that it starts with public and then the return type. The void return type is used to indicate that the method does not return anything. Then it has the method name followed by the parentheses for possible parameters. The body of the method is in curly brackets. Notice that a method can access and use the instant variables in the class email and phone number. The instant variables are shared by the other methods of the class. And here you see that we are just printing off the name, email, phone number, and it's within our public print. To call a method, to do its job, we create an object of the class and then use the dot operator to call its public method. For example, P1 print means P1's print method. Kids, this is like turtle dot forward. So same thing, P1 dot print. Nothing new here. Click on all lines of code that are part of the method in the following class. Well, we have our voids there, right, kids? This is also part of it because it's in its little curly Q. These right here and this one right here. So our methods are just the public classes here. In object-oriented design, OOD, programmers first decide which classes are needed to solve a problem and then figure out the data and methods in each class. For example, here in the class diagram for the turtle class that we've seen before, the in front of the attribute indicates that they are private. The plus in front of the method indicates they are public. There's a tutorial that explains this, kids. Again, I recommend you go there. We're not going to do this in the class. Just so you know, class diagrams are not on the exam. If you do want to draw your own, you can go to this website. It'll help you out. Here's a super helpful hint. When you're given a problem specification, look for the nouns to identify what classes you need to create. For example, in the problem below, you've been hired by your school to create a program that keeps track of students at your school and courses they're taking. Kids, if your school isn't doing that, you should probably look for a new school. Name 2 classes that you would create in your program. Name 2 attributes. That's the data kept inside. What do we have to do then? Well, we need a class. And then we're going to need an attribute. I think I spelled that right, kids. Well, the class, what do we need to keep a track of? Well, students at a school and courses. So I'm going to say one is going to be a student. Would an attribute of that be? Well, that would be something like student name. That's a name we could use to keep track of that. For our second part, we have to keep track of the course. We're going to put course here. Kids, I keep doing that. Tab does not work. For this, what would be that? Well, course name. 2 nouns and a problem description above, student and course, would make great class names. Kids, I thought of that before I read that. Then you can think about what data you need to keep track of for your students and courses and what methods you need. Note that the instant variables in the person class could also work for a student class. Nice little hint there, kids. Say you want to make a computer game from a board game that you're playing. Think about what objects are in the game. For example, here's a description for Monopoly. Trademark Hasbro. Please don't give me some DRM on this. Buy, sell, dream, and scheme your way to riches. Players buy and sell and trade to win. Buy houses and hotels in your property and bankrupt other opponents to win it all. Chance and community chess cards can change anything. What classes would you need to create a computer version of this game? Remember to look for nouns. Take one of the classes you listed and try to come up with 2 pieces of data that would be in those instance variables. Well, let's go down here, kids. First, we want our classes. And in our classes, we're looking for names, right? Like the player, maybe the property, maybe the chance card that they have, or the community card. Stuff like that, right? So those are going to be the classes. And under attributes, well, that could be maybe the position and maybe the money total, stuff like that. And then the property attribute, well, that could be the name, maybe the value, maybe the number of houses or the number of hotels. So kids, you can start seeing the list we're coming up with here. The player, the larger class, those are going to be the big things. Some attributes, maybe the position or money total. And then maybe a property attribute that could be the name, the value, whatever's going on there, kids. Ooh, we have a programming challenge. In this project, you will create a class that can tell riddles like the following. Riddle question: why did the chicken cross the playground? Riddle answer: to get to the other slide. Kids, you're going to do a little thinking about this. What should we call your class? What data does it need to keep track of in the instant variables? What is the data type for the instance variables? What are the methods we need? All of this stuff here. And again, kids, you can go to this website. It'll help you plan it out. But we're going to talk it through here. We can use the person class from above as a guide and write a riddle class in the active template below. It has 2 instant variables for the riddle's question and answer. A constructor initializes the riddle and 2 methods to ask the riddle and answer the riddle. Hint, don't use the name instant variables, int question, int answer. You're going to see as we write this, kids. If you come up with other instant variables and methods for the class, you can add those too. Don't forget to specify the private and public access modifiers. Use the outline in the active code below. You'll learn to write constructors and other methods and details in the next lesson. Really, kids, what we're going to do is complete the main method of constructors with at least 2 riddle objects and call their print questions and print answer methods to ask and answer the riddle. We can look up some good ones online. Kids, we don't have to, because I am the riddler. Wait, the riddle master? Riddle something, kids. We're really just going to look at that one above, and we're just going to work our way through it. That person example really gave us the answer. And the comments, well, it helps out quite a bit. We have our public class here. We're going to write 2 instant variables for our riddles and questions, private type of variable name. So we're just writing some variable names here. So what are we going to do? Well, we're going to create our private, because we want it within this class. And we're going to create a string, because we're going to store words. And we want it to be a riddle question for the first one. Kids, we have to create a riddle question and a riddle answer. So we're going to do a riddle string, riddle answer right here. That's just creating my 2 instance variables. Down here, we have a constructor already written for us in question and answer. That's why they didn't want us to use it, kids. What we have to do is we have to set these equal to those. So we have to set the instant variables to the int parameter up here. How do we do that? Well, that's pretty easy, kids. We just go riddle question, and we're going to set that equal to int question. We're going to do that again. We're going to do a riddle answer, and that's going to be equal to int answer. Created a variable. We're just setting it equal to the parameters inside. Down here, we're going to print a riddle question. The riddle question is, kids, this is just going to be our system.out.print ln. And what's it going to be? Well, our riddle question. That is just constructing for our riddle question. We have to do our answer. So we're going to do the same thing down here. We're going to come over and we're just going to do a system.out.print ln riddle answer. And that's just printing off the question and the answer. We have yet to tell it yet. If we come down here, this is where we're going to create our actual riddles and then call them. Up here, this just said what we're doing. Creating and constructing it. That means our part up here, riddle, is going to be part question, part answer. Now to call the constructor, kids, all we're going to do is the same thing we did with the turtles. We've done this a ton of times. We're going to that riddle class. We're going to create a new instance of it, R1. Ooh, our thing's starting to make sense, kids. We're going to create a new instance of a riddle, and we're going to add those parameters. And what was that joke up here, kids? Why did the chicken cross the playground? That's our question, and then the answer is going to be to get to the other slide. And these are in quotes, kids, because again, we want them exactly. And that's just our parameter question, our parameter answer. And we can test that, kids, because we can come down here and we can just do R1 dot print question from above. And that should print off, why did the chicken cross the playground? Oh, we got an error. Looks like I forgot a curly Q, kids. Oh, not a curly Q, a semicolon. Let's try this again. And you can see, why did the chicken cross the playground? And that was to, well, it doesn't look like we got our question. Oh, we just printed off our question, kids. We also have to print off our answer, because that's a part of it too. And there you see, we are just printing off those parts right there. So the question and answer. And we can do this again. We can make a new instance. Riddle, we're going to call it R2. We're going to create a new riddle. We have to follow the parameters. What days of the week do fish hate? Kids, this is my favorite joke. Friday. Wow, wow. And then if we come down here, we can go r2.print question. And then r2 print answer. And we should get our jokes. What day of the week? What day? Oh, kids, I butchered that, didn't I? What day of the week do fish hate? Friday. And we can keep adding to this by just adding new constructors to the method that we built up here. So again, what do? We created the private string, which is going to be within the class of riddle. We set these variables to the parameter. We did print answer, and that just tells you when we use that command, we are just getting whatever we are doing, either the question or answer. We created 2 new instances of the riddle class, R1 and R2, with 2 very good jokes. And then we just printed off what those instances were. Pretty neat if you ask me, kids. You're going to have to add one more, but that shouldn't be too difficult if you've been following along. We have the summary here, kids. Programmers use code to represent a physical object or non-physical concept, real or imagined, by defining a class based on the attributes or behaviors of the object or concept. Instant variables define the attributes or data needs for objects, and methods define the behaviors or functions of the object. Kids, if you paid attention to anything in this video, pay attention to that line right there. That's going to come back quite a bit. Data encapsulation is a technique in which the implementation details of a class are kept hidden from the user. The data is kept private with access only through the public methods that can act on the data in the class. Pretty neat, kids. If you're into security, there's a whole rabbit hole you can go down there. The keywords public and private affect the access of classes, data, and constructors, and methods. The keywords private restrict the access to the declaring class, while the keyword public allow access from classes outside the declaring class. Instant variables are encapsulated using the private access modifier, and methods can be public or private, but they are usually public. Whew, that's a heck of a summary, kids. Looks like we have some AP questions to do before we're done. Let's take a look at them. This is a pretty long one, kids. Consider the cat class, which contains a string and an int attribute for the cat's name and age, is a constructor. We have our public class cat, and then it's have a bunch of missing code, and we have all these down here. We have our public string name and int, and cat. Well, kids, I'm pretty sure it should be a private string, a private int, and then a public, so that one's not right. The next one is a public, and then we have a private int age, string name, and a string name there. We come here, we have a public string name, we have a private int age, another private cat string name. And then finally, we have a private string name, a private int age, a private cat. What we need is a private public. I think that's B. Looks like we're right, kids. We have another one here. Consider the party class below, which will contain 3 int attributes for a number of people, a volume of music, and a number of boxes of pizza, a constructor class, and a start party method. Well, that's the roads method. The start party method is intended to be accessed outside of the class. That's an important part there. So start party probably has to be a public. We have our public class method. And if we go down here, remember, start party has to be public. So I'm going to start there. Well, that's private, so that's not right. This one's public. This one is public. This one's private. So it's really down to B and C. I know my variable declarations here should be private. They're public here. I'm going to click on be there. And let's see if I'm right. Yay. And there you go, kids. That's our first lesson in writing our own classes. Pretty easy. It's actually stuff we've already done. You're just taking a little more control of it than you have been. Think of a learner's permit. You've been driving with the adults. Well, kids, you just got your license. Time for you to take the wheel. Hopefully you found this video helpful. As always, if you have any questions, let me know. Otherwise, I'll see you on the next video. See you later, kids. Bye. Bye.